Full power operation of a solar dynamic test facility is now in progress at the Rocketdyne division of Rockwell International. The 336 mirrors in the 36-foot parabolic dish were individually targeted prior to installation of the test article. The test article itself was then installed at the focal point of the mirrors to receive sunlight to power a heat engine. The entire assembly automatically tracks the sun, focusing 71 kilowatts of thermal power on the receiver. The full power tests, now in progress, simulate conditions for an organic Rankine cycle space station power system using lithium hydroxide as the phase change salt. Later tests will simulate a closed Brayton cycle using a different eutectic salt compound. A typical test sequence starts by aligning the dish to bring the reflected sunlight into focus on water-cooled doors in front of the receiver. The doors are then rapidly opened, allowing the solar flux to fall into the receiver, heating a eutectic mixture of sodium and potassium, commonly called NaC. In this test, NaC simulates the working fluid of an integral receiver thermal energy storage unit. The molten NaC carries the thermal energy to the thermal storage unit where it heats the phase change salt, melting it, thus storing heat energy. The test article also contains an air blast heat exchanger which simulates an engine in a space station application. Key parameters such as insulation and flow rate are closely monitored in a control facility throughout the test operations. A continuous plot is maintained on receiver inlet and outlet temperatures, thermal storage outlet temperature, and heat exchanger temperature. The thermal storage unit in the test article was first evaluated in a liquid metal development laboratory. The unit is an array of tubes containing selected salts, which are alternately melted to store energy or allowed to freeze, releasing the heat of fusion to the thermal cycle. During a test, the dish is kept aligned with the receiver for a period of 60 minutes, simulating the time that the space station power system is in the sun. The doors are then closed and the system is detracked for 34 minutes to simulate the space station being in the Earth's shadow or eclipse. This cycle is repeated several times to parallel typical operations. On the first test series, a peak temperature of approximately 1,000 degrees Fahrenheit was achieved for the outlet of the receiver. Results will be analyzed to provide hardware data for the NASA Lewis Research Center to support the decision for the initial NASA Space Station electrical power system. Results of this initial run demonstrate the technical process of storing energy by showing that with a step change in thermal storage unit inlet temperature, the thermal storage unit outlet temperature remained approximately constant. Tests on the solar dynamic test facility will be completed in late 1986.